Thanks for letting me freestyle and do a little bit of karaoke with Monster by Future just now, guys. Appreciate it. Whew. All right. So here we go. Today we are looking at changing that first and foremost because I hate it. 4.3 is our focus today. Now, if you didn't recall, we are going to go through 4.4 and then we're going to take a test on the first half of the chapter because there's like 8 sections. It's huge. It leaves us at a really nice place to assess first before we put it all together. So in 4.3, we are going to be talking about the mean value theorem. That is our entire focus. The mean value theorem. And remind me real quick, because it's been a while, I did not teach any of your algebra classes. What is a mean? An average. Okay, so we can think of this thing as just saying the average value theorem. Just so you know, I will probably write this one, but there is an accepted shorthand among the math community. Go out on a limb. What do you think it is? MVT, 100%. The mean value theorem. Now, we're going to see this theorem show up twice, and it's going to show up right now with what we're doing. It's called differential calculus. It'll show up again in a month or two with integral calculus as well, because we get to see the other side of the coin, which is pretty cool. But in here, we start with a special case of the mean value theorem. And we're going to talk about Rolle's theorem. And it looks like roll, but Rolle's theorem. Okay, for this, I'm going to sketch a picture for us to make sense of this, and you guys are going to help me see if it seems reasonable. We are going to sketch a continuous function on a closed interval. So we're going from A to B, and we'll just define that first, and we'll sketch a picture together. So let f of x, some function, and we're just automatically jumping into our theorem, be defined, which means there's no holes or asymptotes, on some interval, so we'll say A to B. And it's a closed interval, which means we get to include both endpoints. So we have a function, f, and it's defined. Cool. What we know more about this is 3 little things, where, or with, and we're going to list 3 comments. The first of these comments is that f is continuous. Now, it's not guaranteed to be the case, but we always hope for a nice polynomial function, like whether it's cubed or to the 4th, doesn't matter. If it's a nice continuous curve, it's convenient. Beyond that, we need it to be continuous, but we also need f prime of x exists. And we can never take the derivative at an endpoint of something because we need to approach the same from the left and right. But we're going to say exists on the open interval. So anywhere between A and B, if we exclude the endpoints, the derivative exists. And then the last criteria for this is for Rolle's theorem, we require that f of A equals f of B. And what's crazy about this is we've already used Rolle's theorem. Rolle, sorry, I'm going to call it Rolle's like over and over. I'm going to mess it up. I think he's a French guy. Anyway, we've already talked about this. And I'm just going to check and see if you guys can remember this idea without even mentioning his name. What's my average speed over the course of a day? 0. Why? Because I start where I stop. Is that like saying f of wake up is f of sleep? Like it's the same idea here, right? So when we sketch this situation, this is just the mean value theorem, which I don't think we've seen. Have we seen the mean value theorem before? Okay, I know we've seen intermediate value because we did that in pre-calc and it shows up in algebra. But here we go. Let's get a picture for this. If you give me this stuff and it's all here, and we're just going to sketch this graph. So here it is, and I'm just going to have A to B be in quadrants 1 and 4 just so it's nice. And let's just pick A's and B's. So here's A hypothetically, and here's B. Now, if this is the case, and these are equal, it doesn't matter where we start and end as long as it's the same value. So maybe I start here, and I end here. And here's the cool part. I don't care what you do, but without picking up your pencil or having sharp turns or cusps, I want you to connect these two. It can be as crazy or as boring as you want. A straight line would be like super boring, so I probably wouldn't just do a straight line between them. Some sort of curve, a nice continuous function between them. Perfect. It's going to be judgy. Perfect. Perfect. Yours isn't a function. Why not?
Oh, sorry.
Nope, don't be sorry. You didn't hurt me. Why is this not a function? What don't I pass?
Oh, the vertical.
Yep, you got to pass it. But I like the idea. I like the curviness. All right. Love it. As long as it's a function, I'm just going to double check. Cool. Yeah, yours is crazy. I like it. Okay, so check this out. Mine's going to be boring. Not boring, but it's what a lot of people did. I'm fine with this. Is that continuous and differentiable? Sweet. And I know that f of a and f of b are the same. Check this out. Rolle's theorem simply says that if you give me all this, and I'm going to go back to purple here, then from all of this, I'm going to just draw this bracket and use this symbol. And can you guys remind me of what this symbol means? Not therefore, but I like the idea. Implies or produces, like this is what we get out of it, kind of like therefore, but because we have this, then this, this is then, if then. If all of this is given, and here's a picture of all that, then there exists, and I would use the backward capital E if I were you, but there exists a value C somewhere between A and B, at least one. There exists a value C between A and B such that f prime of that value is equal to 0. Now, this is a special case of the mean value theorem, which we'll see in just a moment. And it turns out that this special case was needed to first prove the mean value theorem. What I want you guys to do, and you don't have to do this, especially you, Mickey, you don't have to do this 30 times on your intervals, but is there a place where if I think about the derivative on my graph that it's 0 if I take the derivative? Is it here? Everybody hoot and holler when I get there. Okay, it's, I like it. This one, that's a value of C. Do I have another value that exists? Yes, but it's not guaranteed by this theorem. This thing simply says there's at least one. Now, I happen to have 2. Mickey, can I steal yours for just a second? I'm going to call this C1 and C2 because I happen to have 2. And just because I like your graph, Mickey might just have a couple more than us. Is there at least one C value where this happens? Above and beyond. I love it. Okay. Now, there's like 12 of them there, but is there at least one? Do you think you could draw a function between those that is continuous, the derivative is defined, where this doesn't happen? Are you going to be able to do that? Can you connect these 2 points and there won't be a value of C where it's equal to 0? I don't think so, because no matter what you try, it's always going to happen. Like, looking at it, you don't have to add anything to yours, but somebody's initial first thought might be, oh yeah, I'll just do this. That'll show them. But how many C's did we just find? Infinitely many, so definitely not none. We got a lot. You can't do it. Like, if I do this, maybe, but this doesn't work for the theorem. Why? It's not continuous. Okay, so maybe this then. Why doesn't that work for this theorem? It's a cusp. That's not differentiable here. There's not a way that we can do this where this isn't true. And this is a very specific case, right? And when we saw this earlier in the year, we simply said that, hey, there's somewhere on here where my average rate of change is equal to my instantaneous rate of change. That's what we said somewhere earlier this year, and it's exactly what we're going to say for the second part. Can we move on past Rolle and get to the bigger picture? The significance of this, and I like legitimately, I talk so much smack about this over the years because the mean value theorem is more useful, much more useful than this, but this was used to prove the mean value theorem. So I'm fine with Rolle's theorem. If the average rate of change is 0, then there's somewhere where the derivative is 0. That's what it's saying. Let's get to the cooler part of this story and the real focus for today, where we're going to start with the MVT, which I'll write it out one more time. But what is MVT? It's the mean value theorem. Okay, would you like a quick brain break before we do the mean value theorem? Okay, the way that I said that, it sounded like a question, but I did not end with an upward inflection. So it didn't really sound like a question anymore. Do you guys agree with that? Yeah. Okay, so here's the weird part. If I want to say, what? And I'll pause it. If you guys want to know about this awesome brain break, comment below, smash that like button, and maybe I'll make another video about this. So anyway, I can't do it. It's not even me. The mean value theorem. Check it out. This Rolle's theorem works if these are the same. Is there a natural question that you might inquire, that I want you to inquire about regarding these? What if they're not? I don't remember the mark that we need to add on that, but there's some sort of punctuation for it. What if they're not the same? So let's check it out. We're going to start the theorem pretty similar. Let f be defined. Be defined and continuous on some closed interval from a to b, and differentiable, which I'm going to use a super shorthand, diffable, on the open a to b. Okay, here's like the if part. If you give me a function that's defined and continuous and differentiable on this range, then we're going to think about the conclusion, but we're going to make a picture first, and you guys are going to try to reach the conclusion, just your gut conclusion, for the start of class tomorrow. I'm only drawing in quadrant 1, and I'm going to draw very similar to the first one, except it's going to start and end at a different point. So here it is. A, and it's closed, to B. And it's also closed. Based on what we saw with Rolle and the fact that Rolle was used to prove this, I want you guys to think this evening, and at the start of class tomorrow, I'm going to ask, what do you expect the conclusion to be? Now, you can cheat and look at your text. Not that it's really cheating, because I think it's awesome if you're looking at your text to learn stuff. But I'm more curious about what's your gut say. If you haven't looked yet, tomorrow at the start of class, I guarantee I'll probably use it as a bell ringer. I guarantee probably. That's a silly thing to say. I'm going to check with you guys. What does your gut say we should write here based on what we did a minute ago? But that's the end of class. You guys have a wonderful day. And JJ, I will look at this. I don't know why it's not working again. If you want to borrow mine, you can. Cool. Lady Raiders, good luck this evening. I hope you're watching this video.